Okay, good morning. Let's start at 10 sharp in good German tradition. I'm super happy that quite a few people are here, like for the first track, and you immediately all want to hear about security, everyone's favorite topic, especially for developers. My name is Alex. If you have any questions, you can ping me on Twitter or drop me an email after the talk. And basically my goal today is to sort of help you improve the security in your own apps by taking a look at what Elasticsearch is doing in order to run as secure as possible. Elasticsearch is just the code I'm most comfortable with, as I've been a developer for 6 years within the Elasticsearch team. So I work for Elastic. Right now as a community advocate. I've been working at Elastic for 6.5 years. I also work fully distributed, so if you have any questions why I will never ever sign a contract again, which forces me to go to an office, drop me a note. And I want to talk about improving application security with the example of the Elastic Stack. So you might have heard of this wonderful stack of Elasticsearch, Kibana, Beats, and Logstash. Consider it a set of building blocks. You don't need all of the products, with the exception of Elasticsearch. Everything you search at Wikipedia is Elasticsearch. Everything you search at GitHub, everything you search on Stack Overflow is at the end reaching an Elasticsearch node. But if you, for example, index more machine kind of data like log files, metrics, APM data, you may want to take a look at Beats or Logstash. And if you want to visualize or manage and monitor things, you may want to take a look at Kibana. So think of it as sort of building blocks. Before I joined Elastic, I was basically developing a product search engine based on Elasticsearch and a B2B marketplace with all the fun of German search and all its intricacies. And that's going to be our topic today, Elasticsearch. So let's do a quick overview of what Elasticsearch is, just one slide and that's it. Elasticsearch is a search engine. You can use it for full text search, like what I did as a product search engine. You can do analytics or business intelligence. You can do geo-based searching with it. You can combine all of those three, and it runs in near real time, which basically means the duration between indexing data and having the availability to search for it should be as small as possible. It's distributed, so and scalable. You can run it on one node on your notebook. You can run it on 100 or 1,000 nodes in a cluster. And that's the scale part. You can use scale up, like just buy bigger machines, or you can do scale out, just add more machines to a cluster. It's highly available, which of course is a hard term because if you add more machines, failure will become more likely. But it's resilient in terms of figuring out that a node fails and then tries to heal itself without having any manual intervention, like ensuring that all the configuration you did in terms of the number of copies of your data in your cluster will be set properly across your nodes. The interface is HTTP and JSON. Basically, we just hope that every developer knows HTTP and JSON as a protocol and object notation, so that you don't have to work on anything. Also, it's available in pretty much every programming language. Elasticsearch is the heart of the Elastic Stack, and from a security perspective, we can be pretty sure that there are like tens of thousands of clusters worldwide with hundreds of thousands of instances running. And this means that the attack surface compared to other products is much, much bigger. If you find a security hole in Elasticsearch, the impact is much bigger than if you find a security hole in a product that is only deployed once on Earth. And the idea today is not that I'm going to talk about features like authentication, authorization, TLS, these kind of things, but I want to talk about what we do to keep Elasticsearch as secure as possible without you having to do any configuration. Also, naming is hard. If you translate security and safety to German, it both at the end of the day means Sicherheit, which also ends up in very interesting marketing brochures every now and then. But it also means like those borders are kind of blurry. Like there are a couple of things where it's easy to say this is a security feature, like not running as root. Integrity checks is a bit harder. If you do an integrity check as part of a TLS packet to make sure no one has tampered your data sending over the wire, it's a security feature. If you use integrity checks and checksumming for data you write to disk to make sure there's no bits being flipped when writing data, it's more of a resiliency or safety feature, so sometimes the borders are just blurry. If you're a Java developer, you already for sure have encountered the out-of-memory exception. And after an out-of-memory exception, the behavior on the JVM is sort of undefined, so if you prevent an out-of-memory exception, this is a security or a resiliency feature or safety one. If you allow to execute other people's code via scripting or any other engine within your own product, and the user is able to call system exit to stop the process, that's a problem. On the one hand, the moment your process stops, there's no security problem anymore. On the other hand, your process is not available, so you should try to prevent this. Also, if you have your own system that writes data to disk, and I'm pretty sure every one of you is logging some data at some point, do you know what happens when you're running out of disk space? Do you have a test for this, how your application behaves? In the example of Lucene, this might lead to data corruption, so of course we want to make sure that doesn't happen. So we do have plenty of tests that change the behavior of Elasticsearch and stop indexing when running out of disk space. Okay, so what are we going to talk today about? I want to talk about sandboxing. I want to talk about sandboxing your own code, why you should do this, why you should sandbox other people's code, which is usually more intuitive. I want to talk about Seccomp, preventing system call executions, and I want to talk about making sure that the system, which you probably worked on as a product, but runs on other people's systems, is running in a way that it's secure and safe and configured the way you would like it to be. So this is all a bit of sandboxing. We should probably talk about what a sandbox is. So let's imagine for a moment we have our wonderful fancy code over here, and we connect to another host over the network. In terms of Elasticsearch, talking to another node in a cluster is quite a good thing, so I'm really happy that you can connect to another node. If you want to write a log file entry, you just have to append to a certain file. That's perfectly fine and safe as well. And sometimes you need to delete files. Maybe you don't need them anymore. Maybe the internal cleanup mechanism of Elasticsearch has merged a segment away. So it means these are perfectly fine and legit system calls. However, from a perspective from the operating system, the system call is also just opening a file, right? But it's not a data file, it's etc path.video, where you as a developer would usually say, I really don't want my application to open this file. Maybe this application also sends it around. You also don't want to connect to any fancy website or network port to download the next big Bitcoin miner for your system, right? So this is basically just also a regular network connection, but it's doing something very different than connecting to a node in a cluster. Also, you don't want someone to delete all your data. This is also, from a system perspective view, just an unlink operation, which is very similar to deleting data that is no more needed. So from an operating system perspective, those calls are extremely similar. But from a user's perspective or from a developer's perspective, those are malicious and the others were fine. And this also means that the application developer usually knows best what is a good system call and what is a bad system call, depending on the arguments. And this is basically where the sandbox comes into place, which allows you to sort of create a rule set, and based on this rule set, you just allow certain calls or you reject certain calls. And the more granular you can do this, the better. This usually comes up with the next question, like, why the hell should I sandbox my own code? Because I'm writing the most secure code on earth. Probably that's true, but it's still unlikely. There's always someone smarter than you, no matter what kind of code you wrote. So you should just expect your own code to be exploited. Also, there are unknown attack vectors, right? Like, there are things you just don't know. Think of 2 years ago when the Spectre attack was announced with the sort of random branch prediction and execution of code on CPU level. This is nothing you can really foresee unless you work on developing CPUs, I guess. So it's really hard on the application side of things to deal with those. So maybe sandboxing just helps you to prevent these kind of things for once and all. And the question is always, is it really your code being executed, right? Like, if you open file, it's fine. If you open etc path.video, it's probably not fine. Also, if you just sandbox all of your code in an application, the security model suddenly is much simpler than just picking certain things that you want to sandbox on. And of course, you have the always great discussion in the block list versus allow list. Do you want to block everything and then allow certain things, or do you want to just block certain things and allow everything? And from a security perspective, the pick is pretty easy. The question is usually like, is it so much work that it's worth it to block everything and then allow partial things? All right. Let's do a quick detour to Java and the Java Security Manager. So basically, the Java Security Manager is the implementation of such a sandbox on the JVM level. So it's part of the Java code that gets executed. And to do a little history lesson here, The Java Security Manager used to be used a lot in the time of Java applets, if someone still remembers. And it's basically exactly the same thing what nowadays happens on your browser every day. If you open a website, you're just downloading 3 megabytes of React, whatever, and then this code gets executed locally. So from a security perspective, you're doing pretty much the worst thing, right? You're taking someone else's code, download it locally, execute it on your machine, and just assume everything is fine. Most of the time it is. The reason for this is that all of your browsers pretty much have the exact same sandbox mechanism, right? You can't open etc passwd from within your browser unless you found a security issue within the browser. But this is the whole idea of the sandbox there. And Java applets were basically the exact same mechanism. You took a file from remote, downloaded it, and executed it locally in your browser, and hoped everything was fine. And this code was sandboxed as well. So what happens here is the Java Security Manager sort of wraps around your Java program, and on top of that there's so-called policy. And the policy configures what is allowed, so by default everything's rejected. How does it look like? Pretty much you have a policy configuration file back in the days. This policy configuration file contains certain rule sets, like you should be allowed to read etc Elasticsearch where the configuration file is in. You should be allowed to write warlock Elasticsearch, and you should be able to connect to any socket over the network. And this is the kind of rules that you can basically configure with a policy. And if you now try to open a file which is not in etc Elasticsearch, but in etc Apache or etc passwd, you would simply get a failure. This policy then is basically configured in startup of the JVM. And this is the format that you can set it to. So in this example, this is from one of our plugins, which needs to allow reflection. Reflection from a Java perspective is quite the security nightmare. And reflection means you can basically dynamically introspect all the objects, but you can not only introspect them from a reading perspective, you can also change state. And so you usually don't want to do this, but for most of the templating language, this is the way it actually works. You can also go further, so you can configure a lot of different permissions. So this whole Java Security Manager and permission framework is really, really extensible. This is from another scripting engine within Elasticsearch. So scripting engine means this one can be used to write your own scoring formula if you're unhappy with things like TF-IDF or BM25. And this basically allows you to compile code while Elasticsearch is running and to execute this code. So it basically creates bytecode on the fly, because if you have bytecode, execution is much, much faster than just executing the script over and over again. What you don't want to do is, you don't want to create bytecode, which is the mechanism to do this, to create class loader. But this should not be arbitrary. You want to limit this. So we basically have a dedicated permission for this, which limits the execution to certain classes. And with the Java Security Manager, you can even go further. You can basically only allow actions for certain jar files within your dependencies. So in this example, on build time, we basically replace the node-based netty command with a jar file name of the current netty version. And only code that is within this jar can actually open network sockets or can actually connect over the network to other nodes. So even if you wrote your own plugin and tried to execute code within Elasticsearch that connects over the network, Elasticsearch would simply reject this because you're not part of the netty jar. And you could even go further and only allow dependencies that have been specifically signed with a certain key to grant certain permissions. So the whole Java Security Manager is really, really extensible. Yeah, and this is basically the whole idea. From the Java Security Manager, you have a policy, you configure this policy, you add the policy before execution, and then for everything that needs a permission check, this permission check will be executed. So how is this implemented in the JVM? This is Java.io file, which hopefully no one uses anymore because you have NIO and NIO2 to access IO files. But the idea is pretty much everywhere the same. If you ever debug through the exists method, the first thing you see are those lines of code where there's basically a check for the security manager. And if it's there, there's basically an additional check if this file is allowed to be read. The good thing is that the JIT compiler can optimize this away if you don't use the security manager. But if you use it, there's basically an additional check at the bottom which means, am I allowed to read this file? And if this permission is not granted, a special security exception will be thrown. So let's do a quick security manager summary before continuing. It's quite extensible, and here comes the biggest drawback. You can't just selectively enable the security manager. It's enabled for your whole Java application. And that basically means you need to know what all of your dependencies are executing and what kind of code they're executing. And if you just take a look at the Spring Boot application, it's pretty big, and you will still need to know what all of your dependencies are doing. So it's quite some work to actually get to the state to know what you need to do in order to enable the security manager. And also, not many folks are actually using the security manager in production. For me, Elasticsearch is the only biggest project in the Java space that has a security manager enabled. And this means that there are probably, if you enable it in your own project, executions of code paths in your dependencies that you never thought about. And that also those dependencies and other library developers never thought about. And that is a big problem, because this means you're suddenly running code that does not run in anyone else's CI except in your own system. And of course, it's not protecting against everything. There's still no protection against out of memory. There's still no protection to create Stack Overflow exception or Java agents. Java agents allow you to manipulate the code that is being executed on startup. And if you have a mean Java agent, you could basically completely outlive what you have done with the security manager. Within Elasticsearch, the basic idea is that we have an Elasticsearch core, that we have Elasticsearch modules, and that we have Elasticsearch plugins. Plugins are sort of external things that you can download and install, and modules are the same as plugins, but they are always installed, and we will see in a second why this makes sense. There are different kinds of modules and plugins. Some are supports for scripting languages, some are additional transports. So we have a transport for NET-4, we used to have a transport for NET-3, or for NIO nowadays, or to be able to access further repositories for snapshot restore, these kind of things. Plugins are just zip files. Each one can have its own jars, its own dependencies. This also means that if you have two plugins that have the same dependency in a different version, that's not a problem. The reason for this is that every plugin gets loaded with its own class loader. It's the same mechanism that you may know from things like Apache Tomcat. If you have more than one WAR file, you can basically have different or same dependencies in different WAR files, and they don't collide. And also each plugin can have its own security permissions, and that is one of the reasons why the modules are basically existing, because it allows us to only allow reflection for our scripting language, but you can't use reflection anywhere else in the code base. If you try to do this in the core, if you try to do this in your own plugin, you will get a failure. So basically how this works from an Elasticsearch perspective is that every module, every plugin ships with its own security policy, and that one is applied for this kind of code. So when does all of this happen? Now we kind of go a little bit back from the security manager to how Elasticsearch starts up, because it's important to understand we are doing a couple of different things there, which have nothing to do with security manager, but are still important for security. So we have this JVM startup, where the JVM is basically loading its classes and trying to find the main method and goes from there. The first thing that Elasticsearch needs to do, like pretty much every server-based application, is needs to read its configuration file to figure out like what are my data paths, where I can write data to, where's my log file path, what's the name of the node, how do I connect to other nodes, so all the configurations in there. In Elasticsearch, it's a YAML file. What you also do as a first step is always usually set up logging, create a PID file, so these things that are really essential for initial bootstrapping. The next thing we do is we do a couple of native system calls. One of them is memory locking, for example. The other one is Seccomp, which I'm going to talk about in a second. And only then we set the security manager, because the first two things here, especially the native system calls, require sort of elevated permissions, right? You don't want to allow system calls or native calls after a point in time, but in order to set everything up properly, we have to do this. So we don't start the JVM with the security manager enabled. We have a phase where it's not enabled, and then we basically start everything that's needed and enable the security manager. You can also only set it once, so once you set it, you can't disable it, which kind of makes sense in order to not be able to override it. The next step is to load all of the different plugins. And then we do Bootstrap checks. I'm going to talk about Bootstrap checks in a second as well, because I think it's super, super important to think about this in your own system as well. And only if everything is kind of set up the way that we don't want to stop Elasticsearch anymore because we spotted a misconfiguration or anything like that, only then we enable the network, and then Elasticsearch starts to run off and everything works as expected. Okay, so what kind of checks do we have? One of the things that we really, really want to make sure is that you don't start Elasticsearch as root. And now we come to a sort of fundamental problem that we only write the software, but other people are running it, right? So we don't control the environment they run this in. We don't control anything else except this tiny little bit of code that other people have downloaded and are about to execute. So the question is like, how can we ensure that you don't do something on your own system that we really don't want you to do? And running as root is a good idea for any software, basically. And the way we basically solve this is as part of the startup within the native system calls. And there's basically a simple method where we check, are we running as root? And if that's the case, we simply abort and tell the user, don't run Elasticsearch as root. You can see here that we do a native system call called getEUID. And that one returns 0 if we are root or if we are ID root. You can also see that this check does not work under Windows, so we can't really tell for sure under Windows if this is on an administrator account, but this is basically what we did. All right, Seccomp. Seccomp is another part of our startup within the native system calls. Just out of curiosity, who has ever heard of Seccomp? Hands up. All right, that allows me to pretty much talk anything I want. So the idea of Seccomp is pretty simple. One of the assumptions we do is that the security manager could fail. One of the reasons is that it's only pretty rarely run, so it's not as well tested as applications without the security manager. One of the things we really want to make sure within Elasticsearch is that we never are able to fork a process. Elasticsearch in its code does not need to fork a process. We have thread pools, we run thread, but we never fork an external process after startup. So Seccomp is exactly this. Seccomp allows the process, when it starts up, to tell the operating system, if I ever try to execute code using these system calls, please don't do this. Just abort what I'm trying to do. So we basically can sort of sandbox ourselves and tell the operating system, if I'm doing something stupid, don't let me do it. And the interesting part of Seccomp, it's only called Seccomp under Linux, but there's an equivalent on all of these operating systems, like Windows, Solaris, BSD, OS X. So you don't have really an excuse to not implement something like this. And also the implementation, the class in Elasticsearch, I think it's 500 lines of code for all the different operating systems. So it's not even long. It does look slightly different, and there's a reason to it, how you configure it. So this is Java code, but it pretty much looks like the native code, which you would write in C as well. And it's written in so-called BPF, Berkeley Packet Filter, which you might have heard when you have ever used TCP dump and selected the port or the network, like the expression you selected. That is a BPF program, and the BPF program has a couple of special properties, which basically means that you can create loops, and it always has a dedicated finish. One of the things you really want to make sure, if you check every system call, if it should be executed or not, is that you don't run loops, that you don't slow down the whole program. And this is basically why you have sort of a table of system calls, and then you jump to a defined end, which in this example would mean the operating system should just tell for these system calls that you're not allowed to execute them. From an implementation perspective, you can basically use the so-called JNA library, Java Native Access in Java, to do these calls. So we try to use something called a Seccomp system call. This is a system call for Linux, where you can install a so-called Seccomp policy, which you saw one slide before. If that doesn't work, because it's only supported in newer kernels, there's also a mapping in the PRCTL system call that you can use. And at the end, we pretty much just check, did this work as expected or not? And if we were unable to install the Seccomp filter, we basically abort as well. So this is the whole idea behind the Seccomp box. For us, it's another way of ensuring that we don't execute other people's code. And again, and this is the important part to me, it's really, really easy to implement. You just have to sit down and figure out which system calls are allowed for your system or not. Let's talk about Bootstrap checks. This is less of a security issue for me. It's more of a safety issue because we want to make sure that you're running Elasticsearch in an environment where it's properly configured. So one of the things that we do are the Bootstrap checks at later stage after loading the plugins. One of the reasons is that a plugin can have custom Bootstrap checks. And Bootstrap checks are checks that ensure that the system is configured in a way that we require it to be configured. And like broadly spoken, there are two categories. One is the configuration for the JVM, where you want to make sure that you haven't fiddled with certain things, like setting a serial garbage collector, which would slow up the system tremendously. And the other thing is the operating system, where we want to make sure that we can create enough threads as a user, where we want to make sure that we can open enough file handles. File handles are super important for Elasticsearch and Lucene. So Bootstrap check pretty much looks like this. In this example, it's the maximum file descriptor check, where we check on startup how many files can we open. There's a limit. There's a check for the file descriptor count. And if we cannot open, or if we are only allowed to open less than 65K files, we will throw an exception on startup. But only at a certain position. I'll get to that in a second. Another thing that this kind of infrastructure allows you is suddenly super interesting. If you have this infrastructure to check for certain things on startup, one thing that we did is that on the top right, we added a check that at some point we figured out that under special circumstances, under Java 8 with the G1 garbage collector enabled, there was a corruption in the optimized code that the JVM created, which led to data corruption on disk. This was only under special versions with certain configurations set. And we can basically check on startup if the user is running such a JVM and just exit and tell the user, dear user, please upgrade your JVM or you're risking a data corruption. And this is something that once you have this infrastructure in place, it's suddenly super, super simple. And this only happened for certain versions of Java 8. At some point it was fixed. One more thing to Bootstrap checks. We basically added those checks, or those checks are only run in a production system, and that was another problem we had basically, figuring out if you're running in production. Because again, we don't own the system that you're running on. So what we did is basically, we only run those Bootstrap checks if you are not running on localhost, if you don't bind on localhost, because this is usually how you develop locally, if you run stuff on the notebook. But as soon as the system should form a cluster, we assume that you're running in production, and we're basically executing those checks. We don't execute those checks running on localhost because we just assume you try to test things. Okay, one or two bonus slides regarding ease of use, because this is something that I always find super, super important. Elasticsearch is a YAML file. So what we could do on startup is we could parse this YAML file, just read it into a big hash map, and search for the keys. However, we opted for a different solution. And this solution means you have to register every setting that is applicable in Elasticsearch, in the YAML file. Everything needs to be explicitly configured. Why? There are two things. First, we can configure for every setting a certain amount of properties. For example, we can say this setting should be dynamic, which means you can change it on runtime. Or you can't change it on runtime, so you can only configure it in the configuration file and have to restart the process. We can also say this setting should be filtered, which basically means it's a sensitive setting and should never be exposed in one of our API endpoints. So if you try to retrieve the configuration, the settings from Elasticsearch, this setting in particular will always be filtered out. It still means it's stored in your configuration file, but we changed that over time as well, that you can store certain things in a Java key store, and you can protect this Java key store with a password. But there's one wonderful side effect of forcing everyone, also plugin authors, to register their settings. And that's this. We have a list of settings. So if you should ever try to start Elasticsearch and put a small typo in the configuration up there, what we can do is we can just compare this to the list of settings we have and see if there are similar settings, right? We can just use the Levenstein distance or whatever to see if there are similar settings and just tell the user, look, did you mean this? And also especially that, given the fact that YAML is kind of a really hard to parse file format for humans because of its indentation, it might be much easier to hint the user if there's something wrong compared to just exit or even worse, just start Elasticsearch and ignore this setting, but not tell the user anything, right? Because this doesn't help the user. It makes it really, really hard to debug things. And this is also something that you should just rethink for your own system. I think it's super important to come up with useful error messages. And useful error messages always means that you need to become less lenient and more strict when parsing. And at first, people are always complaining if you become more strict, but at the end, it often means that it's super helpful for users. All right, we're almost done. Security is hard. The most important part here is that it took us, I think, 9 months to add the security manager and all of its features to Elasticsearch. The reason for that was a security problem where someone was able to execute arbitrary code in sort of form of .NET in Elasticsearch 1.4. And then we sat down and thought, like, what should we do about it? And our solution to this was adding the security manager and making sure we don't have this kind of security problem ever again. And that was a problem, or that was a reason why we started adding it, but it was a huge amount of work. Also, when we started this, we started with a sort of a backwards compatibility mode where you could disable the security manager a whole major version long, like in version 2. At some point, we were confident enough to just always enable the security manager, and you don't have any possibility to disable this in Elasticsearch anymore. So whenever you run Elasticsearch, you run with the security manager enabled. All right, back to the summary. I think developers have sort of the biggest impact on security. The main reason is because you know your application. You know what it should be allowed to read, you know what it should be allowed to write. And so you can't just offload this to your system administrator and tell him to come up with a fancy Seccomp policy. It's sort of bound to failure. You can work together, but you can't just outsource these kind of things. Like, security is a super big important part of your application. Also, please don't reinvent features yourself. Like the Seccomp filter policy, you could try to write this in your own application and write a fancy filter there and wrap runtime get exec in Java or whatever to make sure like only certain commands are executed. And this is usually bound to failure. Someone will find a fancy way to execute code or to read a file that he's not supposed to read. So you should make sure that you check out existing features first and only write something yourself if it really needs to. Yeah, and I think as a developer, you're just responsible for writing secure code and to think about attack vectors. It's hard because you always think about the good case. It's kind of what you do. You tend to think about bad cases in tests, but usually it's only a really small subset of bad. So it's really hard from a developer perspective to get this right, but it's as important. Also, maybe an external security audit can help a lot in that regard. Yeah, that's that. All I can say is you should probably check out the Elasticsearch repository and see what we do with Seccomp, see what we do with Security Manager if you're interested in that, because you can just sort of copy-paste and see if it works with your application. I'm done. I will tweet the link to the slides later on after the presentation. I also added a couple of resources in case you're interested. Maybe the Seccomp blog post, the last link, is especially interesting to understand how all this happens, also from a historical point of view. And that's that. We still have 10 minutes left for questions, if there are questions. Thank you. No questions. Amazing. So everyone just gets home, implements Security Manager. It's fine. I appreciate that. If anyone knows other projects running the Security Manager, please drop me a note, because when I prepared those slides, I searched for it, and there's kind of a 10-page document in Apache Tomcat, starting with if you really have to run with the Security Manager enabled, you have to do this 25 steps. But apart from that, it's super rare nowadays, and I'm interested to find more projects doing this. So also other projects using Seccomp policies in order to configure their behavior when they start up. Which usually happens with SE Linux or AppArmor or things like that. So feel free to drop me a note about that. And of course, if you have any further questions about Elasticsearch, just stop by and ask them after the talk. I hope I'll be able to answer or forward it to people who can answer things. Right, no questions. Longer break, I guess. Thank you.